Okay guys, hi, I'm back and I'm going to do right now, I'm going to help you with the worksheet. So I guess I'm on task 6 and I'm going to show you some of this balancing equation worksheet. I'm going to do a few examples with you, so hopefully I will help you understand a bit. Okay, so this was your worksheet. You had 10 questions. This second half is again for my photocopying. So you have 10 questions. I'll do probably 3 with you just to get you some more visual examples. They're kind of long, so I'm hoping they fit on my page. But anyway, nonetheless, well, here we go. Let's do, I don't know, number 2. So it says cobalt 3 bromide plus fluorine yields cobalt 3 fluoride plus bromine. All right, let's see how we do this. So that's what it says. So here's going to be some scrap down here. Some scrap space so that we can look it up. Cobalt 3 bromide. Well, we don't even really have to look because they called it cobalt 3, but we'll have a quick look at this periodic table. Cobalt right here does come in a 3. It's number 27. We know it's cobalt 3, so CO plus 3. So that was easy. And bromide. Well, I can see bromide right here on the periodic table. It's a -1. It's Br -1. So when I crisscross, cobalt 3 bromide looks like this. COBr3. So I'm going to put him up here in this tidy spot. COBr3 plus, got a little blank, fluorine. Well, fluorine's an element by itself. It doesn't have a charge, so we don't use any ions. I can see fluorine right here. It is an F. The only thing when I see an element I have to look for, is it one of my super 7? Is it special super 7? Is it diatomic? And it is. Fluorine is diatomic, so I have to put the 2 here. Okay, so that's the beginning part. And it's going to yield cobalt 3 fluoride. Well, cobalt 3 we know is CO plus 3. If we looked up fluoride on the periodic table, we would see right here it's a -1. F -1. Cobalt 3 fluoride is COF3. So I'm going to write that here. COF3 plus bromine. Bromine is an element by itself, not using the charges. I can see it right here. It's just Br. Only thing I have to look for is it one of my super 7? Is it diatomic? Yes, it is. Right here, it's a super 7, so it's Br2 because it's diatomic and it's always bonded together. Okay, so we went from our words to our formulas. Now we're going to balance it. Again, if you don't like to write it out and you just do it in your head, that's fine with me. I'm just trying to show kids who might need to get a little extra help with it. So there's no polyatomics here. Everybody's an element, so we're just going to write it down. I had COs, I had BRs, I had Fs. CO, BR, F. Okay? How many COs do I have here? I've got 1. BRs, I had 3. Fs, I had 2. Here, COs, I had 1. Fs, I had 3. BRs, I had 2. All right. So cobalts are good. Don't have to do much with that. This bromine has 3. This bromine has 2. What's the common number between 2 and 3? 6. So that's sometimes how you have to look at balancing. I need to get this guy to 6 and this guy to 6. Because if I take them both, take this guy to 4, well, 3 isn't divisible by 4, so that doesn't work. So I've got to get them both to 6. So what do I do on this side to get this bromine to 6? If bromine is here, I put a 2 out front. 2 times 3 is 6. So that gives me a 6 on this bromine. It also changed my cobalt to 2. So I got to fix that. Now, if I get this bromine on this side to 6, what do? I put a 3 out front. 3 times 2 is 6. So we're going to see, so far, our cobalts aren't good, but we're going to continue on, and then we'll go back and look at those if these don't work out. Look, I've got a 2 and a 3 again. Common thing between a 2 and a 3 is a 6. So if I make this guy 6, what do? I put a 3 out front. 3 times 2 is 6. And this guy, what do? He's right here. If I put a 2 out front, 2 times 3 is 6. And that also changed my cobalt to 2. So now look, 2, 6, 6. I have it balanced. Okay? So this is how we did number 2 on the worksheet. So let's flip it over, and I'm going to do number, I don't know. What do we want to do? That one's pretty long. Let's do number 6. I'm trying to keep ones I think I could fit on the page. So number 6 from the worksheet, it's copper, 1 phosphate plus nickel yields nickel, 2 phosphate plus copper. Okay, that's our question. I fit it in, so that's good. Here's our scrap on the bottom to figure out what this stuff is. All right, copper 1 phosphate. Well, it told us it used copper 1. We're going to go look up, though, just to find it so you guys can see. Also, you have to know what the symbol is, so I can see it right here. Copper 1, Cu plus. So copper, we got a Cu plus 1. Phosphate, you get out your polyatomic sheet, and you try to find a phosphate. Can you guys see it right down here? PO4 minus 3, phosphate. PO4 minus 3. We do a crisscross, and we get Cu3PO4. All right? So I'm going to put a blank Cu3PO4. Okay, now nickel, just nickel by itself. So it's an element, it's by itself, it doesn't have a charge. I look up here, nickel, its symbol is Ni. And then the only thing I check is it one of my super 7? It is not. So it's just nickel. Boom, that was easy. Then I go to nickel 2 phosphate. Well, it told me it was nickel 2, so that's not hard. Ni, where is he? Right in the middle, right here. Can you see this? Right here, 28. Nickel 2. So down here, I'm going to do this up. Nickel 2, so it's Ni plus 2. And phosphate, I've just seen. It's PO4 minus 3. So when these two crisscross, I get Ni3, open a bracket, PO4, close the bracket, 2. So that's what nickel 2 phosphate looks like. This 3 is not from nickel 3. This 3 is from the minus 3 charge on phosphate. They crisscross, remember? So put a blank. It's Ni3, open the bracket, PO4, close the bracket, 2. Plus copper. What is copper? Well, we look here. It's an element. It doesn't have a charge when it's just by itself. You might have like a copper counter or a copper bar at a restaurant. It's not like you're getting charged when you touch it. It's copper, okay? It's not copper that's charged. It's just plain copper. So it's Cu. And you're going to look at your diatomic cheat sheet. Make sure it's not one of the super 7, and it's not. So copper's just like that. Now we're going to split it, and we're going to balance it. So I can see here my polyatomic and the PO4 has stayed together. So let's leave that together. And let's do this up. I've got a Cu, I've got PO4, and I've got an Ni in it. PO4 and I. Okay. How many Cus on this side? Well, this side is 3. How many PO4s? 1. How many nickels? 1. This side, how many Cus? 1. How many PO4s? 2. How many nickels? 3. All right. Well, coppers are easy because it's by itself. So we can make this be any number later. That's another trick when you're balancing equations you get after the years. If it's by itself on one side, kind of leave it to the end because you could put any number you wanted here. You could put 16, 8, 14, 32. It doesn't matter because it's easy. It's by itself. It doesn't affect anything else. So if I was going to do this starting out as someone who's done lots of balancing in her life, I would also look at nickel because it's by itself on this side, so I can kind of manipulate that. PO4 is in a compound both times. Let's try to get it balanced and then work around that. So we've got 2 PO4s on this side, 1 PO4 on this side. So if I put a 2 out front, that changes this guy to 2, and it changes my copper to 6. 2 times 3 is 6. All right, so now let's go. This has 6 copper on this side. This has 1. So if I put a 6 out front, that's balanced. That's good. I've got 3 nickel on this side, 1 on this side. If I put a 3 out front, that's balanced. I have 6 2s and 3s. I'm balanced. Okay. All right. I'll do one more because that was the second one. I did number 2. I've done number 6, and I'll do, I don't know, try to find one that looks a little bit hard. Let's do that one. That one looks hard. Number 9. Aluminum chlorate. Yields aluminum chloride plus oxygen. Okay, it's a decomposition. So sometimes these are a little trickier. But that's all right. We got this. So I'm going to do some scrap down here. Aluminum chlorate. Well, we're going to look at aluminum. We know it's charged because it's with something. Aluminum is a +3. Al +3. I'm going to look up chlorate. You can see from your polyatomic sheet. ClO3 -1. What does aluminum chlorate look like? It looks like Al, open the bracket, ClO3, close the bracket, 3. That's aluminum chlorate. So I'm going to put a blank out and go Al, open the bracket, ClO3, close the bracket, 3 is going to yield aluminum chloride. Well, I already know aluminum is a +3 because I already looked it up. Chloride, we know, is from the periodic table. Right here, it's a -1. Cl -1. When we crisscross, we get AlCl3. AlCl3 plus oxygen. Well, it's an element. It's by itself. It's not charged. It's just O. Only thing I got to check when I have an element, is it one of my super 7 or a diatomic element? And it is. So I've got to put a 2 here. All right. Let's balance it. So when I look at my big polyatomic, I can see it's broken apart on this side. It's called a decomposition reaction. So it's a bummer because it's not as easy. So we got to send out each element separate when we're balancing. So what do I have here? I've got an aluminum, I've got chlorine, and I've got oxygen. And on this side, I've got aluminum, chlorine, and oxygen. All right, let's fill in what I have in here. I've got 1 aluminum on this side. I have 3 Cls and 9 oxygen. And on this side, I've got 1 aluminum, I've got 3 Cls, and I've got 2 oxygen. So, this is kind of tricky. So, when I get a big numbers like these, like 9, and I have oxygen by itself, it's hard to sometimes figure out what I want to do. Okay? So right now, these guys all look good. I really would like to get this side to be 9. My 1s line up, my 3s line up. It's just this that doesn't. Well, 2 times what is 9? This is another little trick I'm going to teach you right now. 2 times what is 9? 4.5 times 2 is 9. Okay? So what I really want to do is I'll do it in pencil. I really want to put a 4.5 here. Am I allowed to do that? I'm not. I'm not allowed to do that. But I'm allowed to do it temporarily. This is another little trick. So if I did this, it would be perfect. This 4.5 makes this guy 9. Everybody's balanced. We all love it. But I can't have half. That's not allowed. These have to be whole numbers. So if I put in 4.5, you guys know that these guys are all 1, right? If there says nothing, it means that there's 1. So one little trick to balancing some harder reactions are to put in the number you want. And if we put it in like this, this is balanced. That's a 9. We are all happy, except I can't do the check mark. So one thing I'm allowed to do is I'm allowed to do something temporarily, and then I can multiply the whole thing by 2. See what happens. So I'll use a red pen. If I multiply 1 by 2, I get 2. Actually, I'll use blue. Maybe you can see it better. If I multiply 1 by 2, I get 2. And if I multiply 4.5 times 2, I get 9. Now I have whole numbers. And now I'm perfect. So let's go through and fix these ones. I've got 2 aluminum. I've got, how many chlorine do I have? 2 times 3, right? Can you guys see that? 2 out front, and there was 3 of them. 2 times 3, so I have 6. How many oxygen do I have? Well, 3 times 3 is 9. I had 9 times 2. I have 18 now. And on this side, I've got 2 aluminum. 2 times 3, I've got 6 chlorine. 2 times 9, I've got 18 oxygen. Now I'm balanced. 2, 2, 9. So that's another trick on how to balance tough equations. You can put a 0.5 in temporarily and then multiply the whole thing by 2, because 0.5 times 2 will always get you to a whole number. So that's another little trick on number 9. Hopefully that helped. Hopefully you guys can balance equations a little bit and go back and forth and get the assignment done. Let me know if you have any questions. I'm available for one-on-ones. Thanks. Bye.